so we can look at that some more. Okay, so just to describe the data says that we just need like the title, our names, our research question, and then 1 to 3 paragraphs summarizing and describing our data.
Yeah.
And then just some graphs. So I don't think it'll be too stressful.
That's what I was just going through. So basically, our research question is good. We need to do our name, stuff like that. But 1 to 3 paragraphs summarizing and describing our data. And it seems like there was more information on summarizing and describing data somewhere else. Like guidance or guidelines for those paragraphs. I'm trying to think where I read it. Because we kind of have to come up with what our conclusion was, right? So does that mean we need to do the chi-squared test right now in order to have those to be able to make that information and have that there as well?
Probably. That's why I think I pulled up I pulled it up already too.
Yeah, because before when I was trying to, because it seemed like when you had to do certain tests, you have to do like recoding and stuff like that, and that wasn't working, and I was really frustrated because initially he told me after we did the proportion test, he said a NOVA test would be good, but we were actually looking at the quantitative, not the quantitative data. So then that would take us back to the chi-squared. But he said basically he did analyze descriptives, frequencies. Well, he went, never mind, let me go to the one that actually he had. He did it a couple different times. He did analyze, descriptive, crosstabs, put the rows as colors and the columns as M&M packages. And then he did the chi-squared.
So he said the M&M package as columns.
He had the M&M packages as the columns and the rows as color.
Okay.
But he also mentioned something about how I may have to simplify my SPSS file and just have the total number of M&Ms for each color and then do the chi-squared test on it.
Yeah, okay. Look at that.
Which he said that you could do in the SPSS can do that for you, but I don't know. Some people had it using Excel, and I know when I put in the Excel sheet, when I put my stuff in, you can get the totals really easily for a number per color. And I sent you the Excel sheet with my first 30 that were in it.
Yeah. I can go in and type all that up and then do that.
So he said that if we did the data, sorry,
No,
we had to do the data, the weight cases, and then the count. And then do the analyze descriptive statistics, crosstabs, rows, color, columns, M&M packages, chi-square test, and rows, percentage, and then okay.
Let me.
So did we weight the cases first? I don't remember if the file had cases weighted.
Yep, so I weighted the cases and then go to analyze to crosstabs.
Yeah, crosstabs, rows for color, columns for M&M packages. Then he had the chi-square test. And then the rows, he had percentages, like there was a X mark you could check off for rows under percentages or something.
Yeah, and columns or total.
What was that?
So under percentages, there's row, column, and total. Did he just do rows?
He just did rows. And did okay.
Let's see that. Maybe I can screen share with you what I'm getting. Okay, so this is the.
Yeah, he said that when you get that at the end of it, it should show you the total number for each of the colors or something. And then you could do the,
Okay, so I guess blue, the colors are along here. Oh, and
right?
then the total. But it doesn't add.
If you go clear to the very end on the right-hand side, I think it totals the colors. I think he was trying.
Okay. All right. Yeah. So there's the totals. And then I guess this is the overall total. I would think.
Yes, and there's 115 overall, or 915. That's how many M&Ms we counted.
Okay. And then.
Those are broken up by how many per color.
Mm-hmm.
And then, so I think if we do a spreadsheet with those, then he said, you know, that would, I don't know. That's what he told me to do to get the data, but I think I already have that. Let me look at my wheel. 115 yellow.
So this is red.
Yeah, red is 20. Wait, red I had 118.
Oh, maybe red's right here. Let me go look. Oh, that might be blue actually. Yeah, so it's blue, brown, green, orange, red, yellow. So blue, brown, green. What is it? Red, orange, or orange, red, yellow.
Yep.
Okay.
And those are the numbers that I have on that pie chart that's already done to show the data. And I think that was labeled very well and very helpful because he said that's one thing we would be, you know, kind of graded on was the graph. And I just couldn't get the brown to turn brown because they didn't have an option for that color in the wheel.
It looks fine. I think people can understand it.
But it has it on the key on the right-hand side.
Yeah.
So the descriptive statistic stuff is not going to be on there. Oh, but I did kind of, yeah. So we won't need the other two things I sent to you, but just basically the pie graph. And then we need to figure out, I'm trying to figure where, I don't know if it was in the instructions. Let me look on the class instructions for the project. But it seems like there was more description as far as what we needed to turn in for that project, for the group project.
Word. It doesn't really have anything else, if that's what you're looking for.
Yeah, that's what I was looking, trying to figure out what the, because he says, you know, we're going to need descriptive statistics or something, but I think that's all we're doing because we're doing proportions per color.
Yeah, I don't think it. Yeah.
Okay, so I found the describe the data directions. Okay, let me open those up. Okay. Yeah, the instructions here, it says no more than 2 pages. Describe the data you collected. Summarize your data in 2-3 paragraphs using summary statistics as well as other descriptions useful to providing an overall picture of your data. Include a well-labeled graph appropriate for your data. Your graph should help the reader visualize your data and should be clearly labeled. And that's where it kind of threw me off, was when reading it and it said that you need your as summary statistics. I'm like, okay, what summary statistics do we need for this? What, you know, you can run the test, you can get the graph, but usually when we run a test, we can get some sort of statistics to go with it, right? And I didn't know, you know, like sometimes they'll have, you know, what P was equal to, but we're really not doing a P is equal to.
No.
We're doing, are they equal or are they not? So I guess I need to go back maybe in the chi-square section and see what descriptives we could get from those. Which was in chapter 19, or lesson 19, sorry.
So maybe what we can do is take each of the percentages that we get from.
Which is on the little wheel. It shows you that what percentage or what proportion each one of them is.
Oh, then maybe that's fine. And we'll just write about it, you know, and then we'll have the
Okay, so I did see one where it did the chi-squared test, and it usually has a chi-squared test box, I guess, where it shows your test statistic,
Yeah.
which is the Pearson chi-square likelihood ratio and the n valid cases. Do you have that box in that data that you just ran?
This one?
Yeah, that's what we need. That will be their descriptive statistics. So that's what we need to include in there.
So isn't this supposed to be like 0?
On what?
This bottom part?
Oh, yes, it's supposed to be 0.
So I
And
was
if
looking
it's
at it
not,
like,
then it doesn't work. Right?
not look like 0.
So maybe let's try and run the chi-square test one more time, just in a simple spreadsheet where you just put the total number of M&Ms per color. Maybe we need to simplify it before we do the chi-square test on that data. And that was the way of getting us those numbers, which I already have. So if you can go into starting a new spreadsheet and then just put the colors rather than the package numbers, the colors in one column and the second column doing the number or the count, and then do a chi-square test on it. Does that work?
Probably.
A chi-square test, you have to have 2, don't you? But I guess the colors are what it is. Never mind. You have the colors and the count. Yeah, so the title of one would be color and the other title of column 2 would be count. That would be a string.
It always does 20, right?
It depends on how large your color is going to be. The largest color I think we have is yellow. So it would be, like 7 or something. But it doesn't matter, I don't think.
Color and then count?
Yes. And then we're going to do 0 decimals on that.
So we have.
And then I would do it alphabetical. So start with the blue, and then the brown, and then the green, and then the orange, and then the red, and then the yellow. And the total number of blue was 208. Total number of brown was 112. Total number of green was 170. Total number of orange is 192. Total number of red is 118. Total number of yellow is 115. So we need to do the weight by count first, right?
Yeah, is this it?
Yeah, I'm seeing everything you're doing. I'm just trying to make sure we weight it by count first. I didn't know if you'd already done that.
Oh, maybe you can't see this.
Data, yeah, I didn't see that one. Like when you were weighting the cases. And then do the chi-squared test.
So you just do the data weight by
case, and then you do the count. Make sure the count is the one that we're weighting, but it might already do that one since it's the only numerical one there. And they analyze descriptive statistics. And our row should be our color.
Yep.
Column. And then the column will do count or something. Because it used to be M&M packages, but.
And then chi-squared, and then
rows. Well, I don't know. I don't know if we need rows or not, but let's just check it and see. I don't know if that was his way of giving us individual stuff or to get to where we could get to this point or not. But we can always just not pay attention to that data if we don't need it.
Okay, so this is, okay, so 0.
So that's what we need.
And then this is the little one, so that's better.
Those are our, he was just showing me how to simplify it better, I guess, you know, from what we have to making it to do this. So sending me a copy of these files, you know, the updated ones on what we're changing and doing for the tests and stuff. But we can just copy those and put those in the document that I sent you with the pie graph, and those will be our summary statistics.
Yep. Or do we have to describe them in paragraphs as well?
Let me look again on the instructions. I kind of got hung up on the summary statistics. Your document will be evaluated on accuracy and helpfulness of the concepts of your and summary statistics you chose to include in your write-up. Also be sure your paragraphs include a topic sentence. So we need a topic sentence for each paragraph, 4 to 5 supporting sentences, and a concluding sentence. Be sure your grammar, sentence structure, and spelling are all correct. Your graphs will be evaluated on how well they help your audience visualize your data. So basically, we have to write 1 to 3 paragraphs summarizing our data, kind of the way they do in the book, where they kind of step you through each step and, okay, this is what your HO is, this is what your HA, and state your conclusion, you know, stuff like that, if we take it step by step that way. So we can just do 1 paragraph if we want to, just kind of explaining all that we have there, and then because you kind of show, you kind of tell them your name or whatever, your group, what your research question was, and then you say what you found out, and then you show it with the graphs. So it's kind of preparing them to look at the graphs so they know what they're looking for. And I would be happy to look through that too and be able to, you know, before we submit it, both of us kind of look over it and see if there's anything missing or anything that, you know, any way to describe it. I don't know if this is also a time where we kind of talk about how the packages did not all have equal amounts of M&Ms within the package, or if that's something we even bring up because it's not our hypothesis.
I think that it would probably be fine because it's like, okay, what else did you see from all this?
Right. So I think we kind of look back on the report that we had done where we found the things that we were surprised by and kind of pull that into our describing the data. A topic sentence. Our topic sentences for our data is, and our P was low, right? We had a 0.000, so you reject the null that they're all the same. So we kind of need to bring that into that at least one of the colors does not have equal proportions of, you know, within the M&M package. So I think that's where we kind of answer our hypothesis, right?
Let me see.
For p-value.
So I guess maybe we do a make inference. So maybe the make inference is when we.
Yeah, the making inference, it looks like we're going to be doing 1 to 2 paragraphs discussing whether or not our data meets or fails to meet the requirement for our hypothesis test. So I guess, yeah, that's where we're actually inferring right now. We're just describing the data on what we have. So we don't have to go into the p-value or the alpha test. But I know it did say something about our test statistic, or no, our summary statistics, that we do need to include that in this one from our test, from our graph. Yeah, so it's just basically, we can get away with 2 paragraphs and basically summarizing what we see. Statistics. And like I said, I think the pie chart looked very beautiful. I was proud of it.
That's really good. And it's easy to look at, you know?
Yeah. Well, people should be able to understand that very easily, right? When we're describing what our test is. And
Mm-hmm.
so topic sentence. Oh. So we need minimum of 2 paragraphs. Is that what it said? But it seems like one place it almost said you could get away with 1 paragraph, but I don't know.
I think so, because it only says 1, 2, 3.
Because like in the final project, describe the data directions, it says in 2 to 3 paragraphs. So, and there's not a lot to describe. The graphs are pretty well, so I think we go with the minimum on what we need to do there. But I think I would probably go back through the book and the chapters and see in each chapter how it kind of takes us through, like describe the data. It seems like it takes us through the step to see kind of how they.
Yeah. It's like a lot of the chapters do have that step 1, step 2.
And like if we look in, I guess, is it lesson 18? That's 2 proportions, sorry. Let me go to 19 where they're doing the chi-squared test. See if they have the describe there. If not, they do have one in the lesson right before it. But it seems like they usually take us step by step. That one doesn't specifically have the describe, but the one lesson before it on using proportions does, lesson 18, if you're looking at it, when they used pie charts, I guess. They kind of just gave a 1 paragraph, actually. And it basically just kind of said, when working with quantitative data, it is natural to summarize the data by computing proportions. If someone has the ability to taste PTC, which is what they were checking here, we will call this a success. The sample proportion is defined as the number of successes observed by the total number of observations. For the females, the proportion of sample who could taste was this. So I guess we kind of have to do a summary that way, kind of try to follow that. Because they kind of said what they were looking at, and then they said specifically for their data, they found that the proportion of females who could taste it, or I guess we could state the proportions we found in each color, right, individually were these. And then
colors together.
And then the percentages of each color. It's all it just says is just a really quick little paragraph there, and then it does the directions on how to do a pie chart. And then it goes to the next step 4. So there's in their data, it's really a short paragraph on the describe the data.
What? 4 sentences after the topic sentence? 4 to 5.
They had the topic sentence, and then they had 1, 2, 3 sentences. Well, 4 if you count the next one. And then, yeah, they just did. Well, they also kind of explained when working with data for 2 proportions, graphically displaying data can help us compare it. Pie charts and bar charts are essential tools. So I guess you can kind of describe why you used a pie chart. We thought that this would show the proportions better, and especially show the colors. And
yeah, visually. Okay. Because what we have to do the topic sentence, 4 to 5 supporting sentences, and then a concluding sentence.
Right. That kind of looks. They did a topic sentence and 1, 2, 4 sentences, I guess. 1.
You're
No, 2. It was 3. What was that?
You're looking at lesson 18?
Lesson 18, if you're looking right at the beginning, the very first hypothesis test they take you on, it's under 2.1, step 3, and it has like the D there. Because we're kind of dealing with proportions, and even though it's not 2 proportions, because the next lesson doesn't go in and do the little describe, the little things and tell you what they want. So yeah, if you look at that, it kind of tells you you know, kind of, we're working with quantitative data. No, we're working with quantitative. I thought we were working with categorical data.
Maybe that's why we're not computing proportions. That makes sense. Because step 3 says quantitative, and then it says computing proportions.
Yeah. I guess we kind of state that we were doing categorical data.
And then it's able to summarize the data by computing
a pie chart. And that we did a chi-squared test. I'm trying to remember why, because we're looking at M&M's by color, right? And there's multiple colors, and is that why we would say we had a chi-squared test? Let's see, because we were checking for independence between the colors, if they were all the same or if they were different. But we're still looking at proportions, even though it's categorical proportions.
Okay, so we can use computing proportions.
Proportions for each color.
So
I don't know.
So for the second one, it says for the second sentence, it says if someone has the ability to taste PTC, we call this a success. So
right.
Should we say something like,
if all the colors are the same, if all the proportions of the colors come out equal, we would consider this, but that's what we were testing. So then we would say that was a success because we found out what we were testing, right?
Yeah.
But it isn't that way.
So if all the proportions come out different,
then we realize that they are not. Let's see. I'm going through there to try and word this here. They're not, is what, the color. Well, I don't know. The chi-square test kind of has two things. So like our row and our column was color and count. The color and the count are not independent. Does that make sense? Let me look and see if there's another, because the chi-square is testing for independence. And so, I mean, even though he told me on the of everything that he said and trying to understand these, and I'm still trying to wrap my brain around a lot of it. Because he was saying something about the HO is that they are all equal, and the HA is that they are not all equal. But it seems like when we were stating it for the chi-square test, we had to say the color and the count are not all equal. The color and the count are all equal, but that doesn't really, I think we could just put that in there, I guess, and not have to try and determine exactly like the words we're saying in the chi-squared. Let's see. Yeah, because they have on their null and alternative hypothesis under the chi-square for one of them, the location and the motivation for seeking treatment are independent. And the HA was location and motivation for seeking treatment are not independent. But we're just saying the same, not so much independent.
yeah,
But he told me
could be
HA was that they were.
They don't really depend on each other, the colors.
No.
So I
But
guess if he says that it's fine, then
well, that's the test he told me to do, right? We walked
yeah.
through it last night, and he kind of said the HO is that they are equal, and the HA is that they're not equal.
Mm-hmm.
And so I guess I'm not going to worry so much about the not independent or independent dependent. I would just say equal or are not equal.
Mm-hmm.
And we'll see what he says, but
I mean, yeah, he told me to do a chi-squared, so we did a chi-squared, chi-squared.
yeah, he'll get after you if you don't say it right. Well, he'll correct you. You need to learn this. It's chi-squared.
Well, I just like think of chia.
I know.
Chia seeds.
Especially at Christmas time. I always used to see those commercials at Christmas time.
Oh, really?
Chia.
Yeah. No, that's right.
Christmas gifts, yeah. That was what we need to do for the HOHA. And I think if we kind of just look for the information that it gives us on 18 on the describing, just basically stating that we did categorical data and we did do proportions on the categorical data, right? And that's what we were doing to find out if they were equal.
Mm-hmm. But yeah, I did. So I kind of resemble. I guess I need to reword it, but I put when working with the categorical data, it is natural. I need to like just reword it, but summarize the data by computing proportions. So if we reword it.
And we chose a pie chart because we felt it was the best way to represent our data. Do they call it a pie chart? I think they call it a pie chart.
I think so.
Not like a pie graph, it's a pie chart. Yes, it's a pie chart. And then we showed both the number and the percentage for each color. I think we should put something about there where we do have the number and the percentage for each color within each slice of the pie graph or pie chart.
So we showed the total number of the M&Ms.
The total number of M&Ms, we can say n is equal to 951 or something?
I think it's 915.
915. I knew it had a 9, a 1, and a 5.
And then we also showed the percentage of each one.
To the, yes, in relation to the other colors, we showed that, you know, if you want to say, we showed that, you know, blue was 22.73% within all 60 packages that we looked. You can say within all the 60 packages we observed, 60 packages of fun size M&Ms that we observed, we found that 22.73% of all the M&Ms were of the however many M&Ms was blue. You know, and I guess write in sentence form each of those kind of by each color, and then that will get you
A lot of sentences.
because that's basically what he's saying is just describe the data and then show us a visual picture of it. And on proportions, really, there's not a lot to describe because they are pretty much, you look at it and you can see it. But if we just kind of state that we, you know, what we did, what we were looking at, because before you're doing your hypothesis questions before, so we're not making any decisions or summarizing or analyzing what we've done just yet. That'll be next week. We're just kind of stating this is what we found, this is what we did. And I will be happy to read through it too. I mean, if you get it typed up and want another, I'd like to read it, and then we can both kind of save them and submit it like we're supposed to. But yeah, I think the chi-squared, you know, we could say we did the chi-squared test, you know, kind of put in there, that's what we did, so because they're going to have the chi-square box statistics in the bottom. are, and it seems like it would only have to be, like the first paragraph could kind of just state what we did. This is what we did to get our data. And then the second square, second paragraph could, well, no, this is the information we used. And then the second one could say, this is how we got our data, right?
So are we, which one is the percentages going in? Probably the second one.
Probably the second one. I think the first one we could just kind of go through saying we're doing categorical data, and we found that pie charts, we feel pie charts would be the best way to describe this data.
Okay.
You know, we did a chi-squared, and then do the second one maybe for the results, kind of saying this is the proportions we observed. Does that make sense? Is that? Because I think that would give us our 2 paragraphs. And, they're good paragraphs because one's kind of stating what we did and the other's kind of saying what we saw from it.
I think that sounds good.
And then just put our pictorial representations afterwards.
Okay.
And that's due by when?
I think it's December. Maybe I'm wrong.
Let's see. Due Saturday. And I am leaving on Saturday morning. My sons have a lacrosse tournament in Seattle. So we're going up there and staying the night and coming back on Sunday morning. So if we can get it preferably by tomorrow, I will have a chance to really go through it and then can send it back to you, and then we can submit tomorrow if that works.
Yeah. If that's okay with you. I think Friday would be good for me to send it back.
Yeah, I'd like to get it done Friday to say, okay,
Yeah.
we're done. So yeah, I'm still working through. I got through all the videos for the class, but I didn't have time to fully go through all of the preparation and the worksheet on lesson 22. So I've got to just finish that up today, take my 2 quizzes, and then the only thing I'll have left will be the group project, which will be good to have for tomorrow because I think this will keep me busy for tonight.
I have that tonight too. So
have you watched the videos yet?
No, I was planning on doing that today.
It's a 2-hour video.
Is it?
Yeah, it's, because you're doing the 2 lessons, it's 2 hours long. And then, yeah, and then I watched the videos for each of the